Angular 16 brings some exciting updates like signals. What are Angular signals? Why do we want to use them? Let's have a look. Before we deep dive into Angular signals, let's have a look at what problem Angular signal solves. Let's take a simple example of Angular application. Here we have created a simple Angular application. We have a variable called name and we are displaying the name in HTML using string interpolation. As you can see, when we run the application, we see output as Angular. We also have a change name button. By clicking on that button, we are changing the button text to subscribe. When you are changing a value of a variable name, how Angular knows it needs to update the view and display the updated value? It looks like a magic, but it's not. Angular internally uses something called zone.js to detect changes happening in the application and refreshes the UI when it detects the changes in any component. So, Angular needs to traverse all the components and compare each and every value in order to determine if the value is changed or not. This is okay if the application is small, but in case of large applications, it affects the performance. Okay, now how Angular signals overcome this problem? A signal is a wrapper around the value that can notify interested consumers when that value changes. To create signals, we have to call signal function, which is importing from Angular core. Signals will always have an initial value. It can contain either primitive or complex data structures or objects. In order to read a value from signal, we are going to call its getter function. That is how it knows that you are interested in reading the value of the signal, and it will notify you when value of that signal changes. As you can see, application displays name as Angular and change name button as expected. Now, when I click on change name button, it will call change name function, and in that we are setting new value of the signal. To set new value, we call set method on the signal and pass updated value. And that is how UI is updated with the new value. Signals are more efficient and faster than change detection. Let's dive little more deeper into signals. We can create two types of signals, writable signals and read-only signals. We just saw an example of writable signals, where we can modify the value of the signal. Angular provides API for performing three types of operations on signals. So set operation, update operation and mutate operation. So if you want to change the value directly without looking at the previous value, you can use set. But let's say you want to compute new value of the signal using a previous value, then you have to use the update function. Or let's say you are dealing with objects like array and directly updating the object's value. You can use mutate function and make an internal change without replacing the entire array. There are other types of signals as well, for example computed signals, which derives value from other signals. Let's say you have a signal which is dependent on other signals. For example, you have a signal called full name which is dependent on first name and last name signals. In this case, if either of the first name or last name changes, full name should get updated value. Computed signals are lazily evaluated. What that means is, unless you call the getter method of the computed signal, the function will not be executed. Angular also introduced something called effects. An effect is a function which gets executed when one or more dependent signal value is updated. Effects are really powerful and has multiple functionalities and use cases. We are going to talk more about effects in our upcoming video. Please subscribe to my channel if you want to see similar content. See you in the next video. Until then, bye.